Hello students, hello viewers. Welcome to Senior College Mathematics. Topic of discussion is number-based system. If you are in senior college, you are preparing for WAEC, for NECO, for GC, for NAPTEP, for JAMB, or any other external or entrance examinations into high school, this topic, this lesson is for you. Lesson 11, Basic Operations in base 2, that is binary system. When adding, subtracting, multiplying and dividing, binary system, only 2 digits result, and you know 0 and 1. Examples: carry out the following operations. Example 68, you have 11011 plus 111. Of course, this is base 2, so you arrange the number starting from unit so that the digits will be in the right position. So you add. In base 2, 1 plus 1 is 10. You put down 0, you carry 1. In base 2, 1 plus 1 plus 1 is 11. Put that 1, you carry 1. If you add again, you have 10. Put down 0, you carry 1. If you add, you have 11. Put that 1, you carry 1. If you add, you have 10. That's the 10 that you have here. So you have 1 0 1 0 1 0. Example 69, you have 1 0 0 0 1 minus 1 1 1. So you arrange the number accordingly. You arrange the numbers accordingly for subtraction. 1 minus 1 is 0. 0 minus 1 cannot, so you come here and borrow. That one you borrow becomes 2 in this place. If you borrow from here, here remains 1, here becomes 2 as well. If you borrow from here again, it remains 1 and here becomes 2. So 2 minus 1 is 2. Here 1 minus 1, 0, 1 minus 1, 0. So you have 1 0 as the answer. Example 70, find 101 base 2 square, expressing the answer in base 2. So the square means that you multiply the number by itself in this form. So we have the arrangement for multiplication. So 1 times 1 is 1. 1 times 0, 0. 1 times 1, 1. That is this row you have here. If you multiply by 0, you have this row, 0 all through. If you multiply by 1, you have this last row. Notice that the digit you are used to multiply, your answer starts from under that digit to the left. Then you add. So when you add here, you have 1. If you add here, you have 0. If you add here, you have 10. Put down 0, you carry 1. So when you add, you have 1, and here you have 1. That is 1 1 0 0 1 in base 2. Example 71, you have 1 1 1 1 times 1 0 0 1. You arrange the numbers. If you use the first digit from the right, you have this result. If you use 0, you have this result. If you use 0 again, you have this result, and if you use 1, you have this result. The digit you are using, your answer will start from under that digit to the left. So the next thing is to add. When you add, you have 1 here. When you add, you have 1. When you add, you have 1. When you add here, you have 10. Put that 0, you carry 1. When you add here, you have 10 again. Put that 0, you carry 1. When you add again, you have 10. Put that 0, you carry 1. When you add again, you have 10. And that is what you have here. So you have 1 0 0 0 0 1 1 1. Of course, in base 2. Example 72. Listen attentively. This is division. 1 0 0 1 0 1 0 1 1 divided by 1 1 0 1. What you are dividing is usually inside the box and the divisor is outside. You can divide 1 0 0 1 0 first. When you divide, you have this 1 here. When you multiply, you have this result, and when you subtract, you have this. Following the operation of addition and subtraction, the next digit 1, you bring it down and you have it in this form. If you divide this number by the divisor, it is still small, that is cannot. Cannot means this 0 here. Then the next digit 0, you bring it down. When you divide, you have 1. 1 times the divisor, you have this result, and when you subtract, you have this. After that, the next number there, you bring it down, that is the 1 you have here. When you divide everything, you have this 1. When you multiply, you have this, and when you subtract, you have this. The last digit 1, you bring it down, that is what you have here. You divide it by the divisor, you have 1. When you multiply, you have this, and when you subtract, you have 0. So therefore, 1 0 0 1 0 1 0 1 1 divided by 1 1 0 1 is equal to 1 0 1 1 1. You need to be careful when you are doing this. Example 73. We have 1 1 1 1 1 1 1 1 divided by 1 0 1. What you are dividing is inside the box, while the divisor is outside. So you divide this one first by 101, and you have this. When you multiply 1 by the divisor, you have this result. If you subtract, you have 1 0. You have 1 0. Now you take down the next digit 1. Here becomes 1 0 1. If you divide it by the divisor, you have this 1. When you multiply, no, the operation is DMS. You divide, you multiply, and you subtract. When you multiply, you have this, and when you subtract, nothing is left. This 1 here, you take it down. That is what you have here. Any digit that is coming down, you must divide it. If you divide that 1 by 101 cannot, that is the 0 you have here. The next digit 1, you bring it down, so you have 1 1. Divide by 101, that is cannot, the 0 you have here. Then this digit, you bring it down, you have 1 1 1. Divide by 101, that is the 1 that you have here. Multiply 1 by 101, you have 101. And when you subtract, you have 1 0. The last number there, 1, you bring it down and you have 101. Divide by 101 is 1. 1 times 101 is 101. When you subtract, you have 0. Therefore, the division of this number by this number is 1 1 0 0 1 1, of course, in base 2. Example 74. If all the numbers are in binary, solve the equation s squared minus 11s plus 10 equal to 0. This equation is quadratic, and all we need to do is to factorize. And when factorizing, you look for two factors of 10, the constant terms whose sum is minus 11 in s. So two factors of 10 that can give us minus 11 when added are minus 10 minus 1. To get minus 11s, you have to attach s to minus 10 minus 1. So it becomes minus 10s minus 1s, also written as minus s. The first term, s squared, is there, and the constant term. The purpose is to get 4 terms which you group in twos. The first 2 terms, first group, the last 2 terms, second group. Ensure that you separate the 2 groups with a plus sign. From the first group, s is common, you factor out s. If you divide through that group, s squared minus 10s by s, you have s minus 10. The first term here needs to be positive. For that reason, you factor out minus. Looking at s and 10, nothing is common except 1. So you have minus 1. If you divide through by minus 1, you have s minus 10. Clearly, s minus 10 is common. Then you have s minus 1 remaining that forms the other group. You equate each group to 0. That is s minus 1 equal to 0, or s minus 10 equal to 0. When you transfer the constant terms, minus 1 and minus 10 respectively, to the right hand side, you have s equal to 1 or 10. Of course, 1 and 0, they are in base 2. Example 75. Solve for y in the equation below where all numbers are binary. So you have y divided by y plus 101 equal to 1 1 divided by 1 0 0 0. So this is the equation. What we do here is to clear the fractions from the setting of the equation. The best approach is to cross multiply in this form. So you have y times 1 0 0 0, you have it in this form. Then 1 1 times y plus 101. So you expand this bracket and you have this. And the other side, you collect like terms. This term here, if you transfer it to the left hand side, it becomes negative. From the to the left hand side, yes, from the left hand side, y is common. You take it out for you to see 1 0 0 0 minus 1 1 clearly equal to the right hand side. When you subtract the bracket, you have 101 multiplied by y equal to 1 1 1 1. To get y, divide both sides by 101. So y is equal to 1 1 1 1 divided by 101, and that is 1 1. That is a value of y, and it is in base 2. Example 76. If 1 1 0 1 1 1 in base 2 minus y base 10 is equal to 1 0 1 0 1 base 2, find the value of y. The way it is, all the numbers are not in base 2, so you have to convert to the higher base of 10. You convert this number and the right hand side to base 10, and the approach is continuous multiplication by power expansion. So you convert this to base 10. Following the discussion in lesson 2, you have 55 base 10. The right hand side, you convert it to base 10 also, and you have 21 base 10. What it means is that 55 base 10, that is replacing the first number here, minus y base 10 is equal to 21 base 10, that is replacing the right hand side. You collect equation, so transfer minus y to the right hand side, it becomes positive, and you transfer plus 21 to the left hand side, it becomes negative. So you have 55 minus 21 equal to y, and therefore y is equal to 34. Hello.